Hello and welcome to my ENSE352 project demonstration video. For this project we had to create a simplified game of whack-a-mole using 4 LEDs and 4 push buttons. So first I will start off by explaining my code here. So here we have just some various constants and stuff. So these are just some register addresses here that are not, don't change those. Then we got some most of these are time constants. We have, in this project in this class, we were not taught to use microcontroller timers, so we just have to make the processor count down from a very large number to create delays. So this first one, UC1 light delay. So in our UC1 section, this is the waiting for player section. And so the sequence is that it just turns on each LED one at a time. And so this is just the time between turning the next LED on and turning off the previous. Then these LCG variable are constants here. Those are for the LCG random number generator algorithm that we're using, or a simplified version of it. These UC2 numbers here. So this is the reaction time variable, but this is the starting one, as this number gets divided in half each time for each subsequent round. The preliminary delay, that is the delay at the start of each round before the light is selected. Then this num rounds variable, that is the number of rounds the player has to beat in order to win the game. In this case, I just have it set for 3 for now, and then you can put it up to 15 or 0xf. Because that is the maximum that 4 LEDs can represent. Then this UC3, that section is the success when the player has beat all rounds, and so all LEDs flash on and off in unison 5 times, and so this is just the time constant between the turning on and turning off. UC4, that is the fail section. So this is the in that section, the bottom 2 LEDs turn on, and then it switches to turn on the top 2 LEDs, and this is the time between that alternation. And then UC4 is the score display time. So after the LEDs alternately flash 5 times, then your final score, how many rounds you beat, is displayed for you for about 15 seconds or so, and then it just goes back to wait for a new game to start. So then we just have some stuff to set up the assembly file, and then it starts off by calling this register initialize. So here we just set up, we enable ports A and B, and then PB4, 6, 8, and 9, their default states they default to input with a floating input. So we don't need to change those, but we do need to configure PB0 to be a general purpose output. And then PA0, 1, and 4 we also need to configure as outputs. Then finally, the addresses of the ODR, IDR, and the other ODR for the GPIO A and B ports are loaded into R0 through R2. So we can refer to those addresses later for turning our LEDs on and off, and also reading our buttons. Then we got UC1 here. So this section of code turns each LED on one at a time and turns off the previous one. And then in the delay time between switching the LEDs on and off, the code here checks each button, and if any of them are checked, you can see here BEQ UC2. So if any of those buttons get pressed, the code branches to the UC2, which is our main game here. Here I've got a long explanation for our game here. I'll explain it here. So UC2 is our normal gameplay section. So it starts off this one time here, loads in these various important values into there. So the first R4 and R5, those are for the LCG algorithm. Those are the two constants. Then R8, R9, R11, those are loaded with 0. R8 is our round counter, so this keeps track of how many rounds the player has beat. And in this case, the player would need to beat 3 rounds because it gets compared to this UC2 num rounds there. R9, that loads in our time just for the specific round, as R6 holds the base time, and then that number gets divided by 2 each time and gets reloaded into R9. I'll explain that later. And then R11 contains what button is pressed. So then it turns off our LEDs to refresh the display. Then our preliminary delay is called for the round. Then we check Has the player won? Have they beat all of the number of rounds specified up top? And if not, then we do the random number generator here. Now R3 is our seed, and and on the first round, it happens to contain the leftover time from UC1. So we'll just use so to initialize our random number, we will use the leftover time from UC1. So we generate a random number, then we extract 2 bits from the number. So then that'll result in a value between 0 and 3. But we want to save the value of 0 for something else. So we will add 1 to our answer to force it to be between 1 and 4. So then the code will light up the corresponding LED if the result is 1, 2, 3, or 4. Then we load R9 with our time here. And then we call main game delay and sample loop. So it goes down there. This is the preliminary delay here. It goes down here and checks, is the player out of time? Well, obviously if not, then here it samples each button. And in this case, if it's the black button or the top button, we load a 4. If it's the next one down or the red button, we load a 3. Next one down, we load a 2 into R11. And finally, the bottom blue one will load a 1 into R11 here. So then we check, is R11, the button that was pressed, the same as the LED that was selected? If they are, then we go to the round 1. So here, what the round 1 little function does is it loads the remaining time into R3 here. And so that new remaining time becomes our seed for our random number generator for the next round. Then LEDs are turned off again to refresh the display, and R11 is reinitialized to 0. Then it branches back to the main part of the UC2 here, where we add 1 to our round counter. Then our time is divided in half for the next round, and then it branches back, and we go to the next round here, and we do this all over again. Now, say we're in our game and sample loop here, and say the player has not pressed the button. Well, we know that R11 will stay as 0 because none of the code will load in another value otherwise. So that means this comparison will not be equal. So then we go down here. So first we have the save or link register since we're already in a subroutine. And then we check in this little IT block for the not equal, and we'll branch with a link not equal to button and light not equal here. So we go down here, and first it checks, is R11 0? If it is 0, then we know that the player just hasn't pressed the button yet. So that's fine. It'll just branch back and continue in the delay and sample loop. But if the R11 does contain something that's not 0, well, we know already that the player has pressed the wrong button because we already checked if they did have the correct button up here. So therefore we know that they've pressed the wrong button, and so they have failed. So that means they will go to the fail section. And then of course, if the player beats all of the specified rounds, this comparison will be equal, and so then it'll branch to the win round, or to the win sequence. So then let's check out how our win sequence works. So win sequence is specified here as UC3, or use case 3. So what this code does is it turns on and off all LEDs in unison 5 times, pretty quickly to indicate win, and then it calls game reset 1, which branches back to UC1 to reset the game. Now the reason I can't just directly branch back to UC1 is because I got some relocation errors when I was doing this because I was trying to branch too far due to some offset number or something with these commands. So we'll just branch to the game reset here, and then that'll branch back to UC1, which will take us back to the waiting for player section. All right, so then say the player has failed, and we go to UC4 here. So what happens here? Well, first we clear the display. It didn't matter in the first section because all LEDs flashed in unison, but we do have to clear the display here because what it does is it takes the bottom two LEDs here, turns them on first, then turns these ones off, and then it alternates between these two groups. And it does that alternation, well, 5 times here. So it does that. Then once that's done, then we go to display a round number. And we know that how many rounds the player has beat was stored in R8. So again, the display is cleared, and then it checks what is in R8. And it'll go to the corresponding function depending on how many rounds the player beat. Now in this case, they can beat up to 14 rounds because once you get to 15, that is the maximum that the 4 LED display can display here. So then, go to display 0 or display 1. Now this 14 display, the reason I have to do that is again because of that relocation error, so I just have to have a little assist function here to get me to the 14 displaying function. So then it'll go to the appropriate function here and display how many rounds the player has beat. So then say the player has beat 13 rounds here, and it goes to the display 13 here. So again, it sets up the display, then it branches with link to score display delay. So this function just holds the whatever number was put on our display for it came up to be around 15 seconds, I estimated. Then it branches back, it'll branch back to the display 13 in this case, and then finally score display done, which calls game reset 2, which is here, which calls game reset 1. It's just above the UC3 section here. Where are you? There you go. I'm just trying to find it here. Oh, this is UC2. Where are you? There we go, sorry. It calls game reset 1. And then finally that game reset 1 calls UC3 or UC1, which that goes back to waiting for players. So then now the game has been reset and the game will wait for a new initiation sequence or a new button to be pressed to initiate a new game. So that's how my code works. And here's kind of where things got a little bit funny. So in theory, this code should work. And as you see, here's the waiting for player routine. It just sits there and turns on each LED one at a time. It just repeatedly does that. Just gotta close my door here. The dogs aren't bursting on me. So then it just sits here and does this. But then when I initiate a game here, oh, it didn't actually do it this time. No. So this is what it does. Either it lights up a random LED and then just fails whenever you press any button. And then as you see, it says I beat 0 rounds here. So we'll just wait for it. There, and then it goes back to the waiting for player here. So if we initiate another game, see, it automatically just goes to the fail sequence. And then it'll just sit there and wait and say I beat 0 rounds again. And goes back to wait, initiate a new game, and it just does the fail sequence again. So I am not sure what has gone wrong with it, but I can demo here on this time I decided to display 1. And then it'll go back to waiting for player here. So you see, it doesn't seem to work properly when it's running just on the board, but I can demonstrate that it does work with in a live debug. And as you can see here, we're in debug mode according to the little light there. And we're in debug here. I'll just can I get this a little bit higher? Yes, I can. So here I will just demonstrate a when. So go step. There we go, register initialize. So we can just step through all this, get our register started up here, and go to UC1. So this is the waiting for player section here. Go, there. And so it turns on the first light, just as expected. Now we will we actually do have to step into this thing. So now I just put my phone down, and I will press a black button to initiate a game. Click, click. There we go, I can release it now. It's read it. So it's read our black button, and so R4 should contain, what is R4? Okay. It contains this, but it'll just be shifted over in just a second. There we go. So now R4 contains 0 as expected, because these are active low switches, and so now it will branch to UC2. And there we go. So now we're in the gameplay section here. So we'll load in some values here that need to be loaded in, and turn off LEDs. So there, our LEDs are turned off. Okay, and we'll skip over this preliminary delay because it doesn't do any sampling. So we'll check, does R8 equal 3? And no, it does not. It contains 0 because we haven't beaten any rounds yet. So we'll continue to go here. So generate our random number. So CC1A000, and shifting over, add 1. So we get 3. So that means that D2 here, this guy, should light up. So we'll see if that happens. Okay, and just after this instruction, it should light up. And so there we go. So it does light up. So that means that I need to press red guy here. We'll continue to go, and we'll just check that the top light doesn't light up. And indeed it does not. That second from the top light stays on, which is good. So now we'll call our main game delay and sample loop. But as you can also see here, that R9 and R6 are now equal because R6 has been loaded into R9, which is our time. So we'll go here, there. So now I'll just put my phone down here again, and I'll hold down the red button because that's the button I need to hold down. So we'll read our button here. Okay, I can release it now because it's been read. So R10 will now contain what was in R1, or what our red button is. So we'll just go here and we'll just shift some stuff around and do a compare. Is it not 1? And indeed R10 is 0. So that means it's pressed. So that means R11 will be loaded with 3. And indeed R11 is loaded with 3. And as you can see, R11 is not changing as it samples the other buttons. So now to compare R11 and R7. So R11 is 3, R7 is 3. That means the player pressed the correct button. So now we go to round 1. So the remaining time, we load it into R9 here. Or sorry, load it into R3 here, which was in R9. Then our display is turned off. And so as you can see, the display is cleared. And R11 is reinitialized to 0 for the next round, and BXLR. So then it finishes the round here, so we increment R8 by 1, and divide our time by 2. So as you see, it only affects R6 for now, and so R6 equals 0028 there. And then we'll go back to the main thing here. And my arm is getting very shaky. My left arm's a little bit weak. So then, again, we will do our preliminary delay, and I'll skip over that because there's no sampling in it. And again, R8 is less than UC2 num rounds, as our UC2 number rounds is 3, and R8 currently contains 1. So that means this will not be satisfied. So again, generate a random number. In this case, we now get a 1 in R7 here. So that means our bottommost LED will light up. So just after this store instruction here, and there we go. Our bottom LED is lit up, which means I have to press this blue button. So we'll skip through here to show that the register is not going to change, that R7 is not going to change or anything. There we go. Okay, and as you see, our bottom LED is still lit up here. And then go to delay and sample. So I have to press our blue button here. So click, 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 click. Red button here. Now it checks the green button. Nope. Okay. And now we'll check our blue button, and now it's just sampled our blue button here. Okay. And so R10 currently contains a 0, and so that means it's not 1. That means load R11 with a 1. Boom. R11 contains a 1. And we're on a compare instruction here. So now, R11 contains a 1, R7 contains a 1, which means they are equal. So a round has been won. So that means we do this again. Fun stuff. And then increase our R8 by 1 again. See, R8 now contains a 2. Why is this camera getting all fuzzy? Focus, you stupid thing. There we go. There, divide our time in half again, and now we see R6 contains 0, 0, 14. And do a round again, because R8 is 2, which is not 3. Oh crap, I'm in the delay loops. Okay, we'll step out of him. There we go, that's better. So compare, random number generate again. And we get a 4 this time, so that means our top LED will light up. So let's see if that's right. So again, on our store instruction here, so our top one will light up after this one. And indeed, our top one lights up now. Okay, I'm going to call our sample loop. So now I have to put down my phone and press our black button here, which is the top button. So now, okay, we've sampled our black button. And just finish the shifting here. So now check on R10 here. Okay, R10 contains a 0, which is good. So that means it's not 1. And so we'll load in a 4 into R11 here. And so there's a 4 there. And then it'll sample the other buttons. And as you can see, R11 is not changing. Check blue button. R11 is not changing. Here, compare. So now R11 is 4 and R7 is 4. That means they're equal. That means I've won this round. Hooray. I'm a genius. The XLR back to finish the round and increment the counter by 1. So now this time, once we're done the preliminary delay here, step over. Now our comparison will be good because R8, as you see, contains 3, and UC2 num rounds at the top was also set to 3. So this means step, and hooray, I've won. So now we do our winning sequence here. So step, 13, and then a 1 to the other one. There we go. All LEDs are on. And then, okay, we want to step over the delay here and then turn off both. There we go. Turn off both. And step. Go. There we go. All LEDs are on again. Okay, and LEDs are on again here. Good. Okay, and then LEDs will turn off. There we go. And go again. Where are we at here with our with R4. R4 is on. It's on 1. Okay, so we got just a little bit to go here. Okay, and so LEDs will turn off again. Good. And then branch. Now we'll do this comparison, and as you can see, R4 is now 0. So that means branch to game reset 1, which takes us back to here, back to the waiting for players section. So that means this code works, but only in debug mode. So now I will do another round, but this time I will just purposely fail on the first time to demonstrate the fail sequence. Again, la 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 la, and okay, a little black button. I'll press the red. I'll press the green button this time to initiate the game. Click, 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 click. Okay, it sampled our green button here, and just finish our shifting. And there we go. Start game. Load in the values. Turn off LEDs. And so there we go. Our LEDs are off. Okay, skip over the preliminary delay. Check that I've won, which we haven't because R8 should contain a 0. And indeed it does. Generate a random number. Okay, and this time R7 is a 3. So that means our second from the top is going to light up again. Or D2 will light up here. So just after this store instruction here, boom, it's on. That means I have to press the red button again. There we go, and I'll check that the top guy didn't light up. So that's all fine and dandy. Okay, now I'll be a naughty person this time and press the blue button. This means now, okay, I've pressed the blue button. And so now we're on a compare instruction here. So as you see, R11 contains, what does it contain? It contains a 1. And R7 contains a 3. That's very bad. So that means we go here, and I'll go to this, go to the button light not equal. So that means, and that because R11 button was pressed, that means R11 will not contain 0. So that means it won't do this. That means it'll go to fail. So here we're on our fail section. So first we'll clear out the display. There we go. And set and load R4 with a 5. We don't care what was in R4 previously. So we'll do our first blob here. And so you can see the first 2 LEDs light up. And skip that. Go blah 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 blah. And the next 2 LEDs light up. Go. And so bottom 2 light up. Skip over. Next 2 light up. Sorry, this is giving you motion sickness. Next, the bottom 2 are on again. Okay, there we go. Bottom 2. Come on. Okay, top 2 are on. Where's our 4 at here? It's at 2 still. Oh, great, lovely. It's taking a while. Okay, our 4 is at 1. And we'll turn on a bottom 2. Top 2. And now our 4 is at 0, so that means this will be true. So now I'll go to this display round number. So again, clear out display first. Okay, so what is in R8 here? R8 contains 0. So that means this display 0 will be called. Therefore, technically it was already initialized to 0 anyways. So as you can see, there is a 0 displayed on the LEDs there. There we go. Whoops, I don't want to be in the delay loop. I'll step out. This one does take a little bit of a while to get out of if you step into it. It shouldn't freeze up. There we go. Okay, and now score display done. So this goes to reset game 2. This goes to game reset 1 here, and which goes to UC1, and therefore back to waiting for player. So there we go. I have demonstrated my code as best I can. Again, I am not sure why it only will work in a live debug. Because again, as you can see, I'm just doing waiting for player here. Initialize the game, and then it just goes to fail. So again, I'm not sure what's up with it. But yeah, that is my submission for ENSE352. So yeah.